This conference will now be recorded.
So yesterday's session, just to have seen some basic programming in MapReduce with old API and new API as well, right? And we understood the pattern, how exactly it runs, and we identified the application areas also, where you're going to run the MapReduce. But the core important thing we need to identify here. So MapReduce is a very powerful thing, right? So it's not having any issue with the structured, unstructured, or semi-structured, any kind of data that it can process. But the only issue here is it can understand the things only in the key value format. So there is some predefined input format classes will be there. By using, you can give that input, in a specific format. But sometimes we have to go with more and more hard coding kind of thing also. Like whenever you're having some sequential files, otherwise you're having some group of images and you want to find out the duplicate. So that time you need to convert the things into binary, and then based on the binary format, you need to search that or the duplicates. So a lot of hard coding is really required. It's a powerful thing, but even then, the coding part is very tough, especially the guys who came from other than Java background. Okay, the programmers like .NET or whatever it may be, they can understand the patterns, but the guys who came from the Java, they can understand more. But it's really a tough job for the guys who are not from the Java background. That's the reason why, in market, big high HPS, other tools will be concentrated with the the guys who are from the other background other than from the Java. But nowadays, like, it's somewhat reduced. That people are not using this particular MapReduce APIs and all. But sometimes, whenever you need to go with some user-defined functionality, where you just really missed out your built-in function, or you're looking for some Saturdays, right? Or you need to go with some libraries, must naturally have to go with this particular MapReduce only. There is no other alternative, but this will be taken care by your Java team. So no need to worry. The guys who came from the SQL background are other than Java, right? So now, today we'll see few more programs on advanced MapReduce concept. I'll explain few more programs. You can understand the scenario, and after that, based on the time, we'll run some HBase related stuff also. I forget to share the document yesterday to you, right? Regarding that HBase Java API to understand. Today I'll share that with you. Right, fine. Now these are some use cases that I want to show you, like how you can implement the combiners and partitioners and distributed cache and counters. So we'll see and we'll try to understand business logic as well. So coming to the combiners and partitioners. So already we discussed this topic, right? So generally, you're having a mapper and a reducer. In between, like shuffling and sorting, that will be taken care by the framework. Apart from that, as a developer, we can introduce the combiner as well as the partitioner. Okay, so these combiners can be treated as a mini reducers because of these guys working at the mapper phase. Or for every mapper, sorry, you can run a combiner. So these guys just acting as a local reducers, right? For example, you're having 10 blocks of data maybe. So 10 blocks, 10 mappers that are running. At the same time, you can run 10 combiners. So whenever it's possible, based on the given key, this will be trying to uh, aggregate the job there itself based on the key. It whenever it's possible. Suppose there is nothing is possible in that block, nothing will happen, even though you're implementing the combiner. They don't give any impact, right? That's fine. And what about the partitioner? So partition is something like based on a particular key, just you want to redirect the output. So I'm having a lot of stuff in my thing, but I'm looking for specifically based on a particular partition. I want to particular field. I want to do the partition. So I quickly recap, like what we discussed, this dynamic and manual partitions, same thing, right? So in the manual partition, just we have added extra field like country. There we loaded separate the Indian data and US data. At the same time, dynamic partition category is included in the point of sale data, but even then, right, it's clumsy, really clumsy. You're having a lot of customer IDs and transaction IDs, right? And the different categories. So whenever you want to do any analysis on this given data, we need to have a partition, right? We have to find out the partition. Based on the partition, you can just start the analysis so that you can improvise your where class, right? Once you got the idea, okay, I'm having these many categories. So there we kept partition as a key for us, right? Sorry, category is a partition key for us there that time. So similarly, the same concept can be improvised here also. In a given data, just you can give something as a partition key, and based on that you can perform and you can write direct output. So we'll see for this how we can implement in the business logic, right? Uh, And after that we'll discuss the other two scenarios also. Let us open our virtual machine. Fine. So we will kept the folder for AMR. Yeah, this is the one. Advanced memory use. So all right. So this is a Java program. So we'll understand first of all what are we are doing here. So with partition, just I have given my class name as a partitioner. So we'll start from the driver class. Right. So in the driver, what we define here, just we are like running with a static thing here. So just set the name and we have started the job configuration object here. And if you look at here, I'm asking to run 3 registers for this, right? So like this, you can set number of register tasks also. You can, if you say here 0, what happens? So everything will happen at the mapper end. Nothing will run at the register side. So programmatically, you can define number of reduce tasks also here. So once we set number of reduce tasks is equal to 3 here, so then what happens? 3 reducers will run on a given data set. And after that, if you see, just we have given the mapper class, reducer class, and everything here. Apart from that, if you look at here, this combiner class is also using the reducer only. For the partition class, we define one more class with a name called my partitioner. But if you look at here, the combiner and reducer both are using the same class, isn't it? So reduce class only both these are using. Why? Because to implement the combiner, no need to specify any other business logic because these guys work as a reducer only. So instead of once again, defining a class and using here, what we can do, so just you can say convert set combiner class and just specify your reducer class. That's it. So no need to write any additional business logic for your combiner. Only thing is this reducer is working on the consolidated data, but this guy is working on the mapper level. That's it. And of course, for the partitioner, we implemented one more class. We'll just verify what we implemented in the mapper, reducer, and the partitioner. And same as just we specify the output key class and the value class and the input format and output format, and these are the command line arguments where you're providing the input and where you're going to expect. And finally, you're running this job. So this is about our driver. That's fine. Now, what we specified in our mapper class. So this map is extending the MapReduce base class and implementing the mapper class with the 4 generics. So this is for key 1, value 1, key 2, and the value 2. Right, and our mapper functionality, so this is the key value, and as here we are using the old API, right? So here once again you're getting the output collector and the reporter object, right? So here by looking at this program you can say very easily that you are using the old API because in new API this is replaced with the context object, right? So right, so this is a simple logic on the same word count program what we're doing. So we're defining a line and we're converting everything into a string. Then we're using the string tokenizer to make the chunks, and based on that you just getting the count. That's it. That's fine. There is no problem with the mapper and reducer. The way earlier we worked on this, the same thing remains here also. But if you look at this, we are implementing one more partitioner class here, and here key and iterable. These are the generics what we had to mention. This is for key and this is for the value. So what is the key? For example, in a given data, just you want to get a count how many times Hadoop came and how many times data came. So one partition is created for this and one partition is created for data. And rest all can take one more partition. This is our intentional. So in a given data, for example, you're having any uppercase level or lowercase, whatever it may be, just we're converting the things like Hadoop may be in the uppercase or the lowercase will be converted to this and you'll be getting the count. And same thing is happening for the data also. So if and only your data is consisting of this Hadoop or data, so these are the partition keys here. Got it? The way we specified in our dynamic partition category state like the way. So here our partition keys are Hadoop and data, right? So same thing just be specified in our partition class. So whenever you're having it's your key is equal to this guy, Hadoop or data, just create one partition for this and one partition for this. And if it's not matching with these two, just go with the remaining partition. That's what we specified here. So now we understood the mapper and the the partitioner, and of course finally the reducer. So it's getting like here we are having that key and iterator, because from the multiple mappers it's getting the output. So key will be there and value will be getting after the iterating only or iteration job only, right? So initially we're initializing the sum to 0, then we're getting a count. So based on the given key, that count will be incremented, right? How many times a particular keyword came here. So finally you're getting the output key and the value. For example, hive came this many times, hbase came this many times. So this output collect will print on the console. So this is what exactly we are having in our mapper class and the reducer class and the partitioner, and finally of course the driver. And as specified earlier, for this combiner no need to specify any class, just you have to call the reducer class only, because this combiner class also using the same mechanism of reducer, right? So already we discussed this, right? This guy is working as a local reducer. So that's the reason why you don't need to specify any business logic. Just instead of that, you have to call your reducer class. That's it. Now what we'll do, just to take this into our our project what we created yesterday, and we'll create a class file initially. Then after that we create a jar file. So let us do that initially here. And you just put any name, laterwards you can change that, it's not a problem, right? So I'm closing additional stuff here to add the confusion, right? Now you'll be having more space here. I'm pasting here. So just I need to change this class name. Here the class name is with partitioner. That's it. Fine. So no need to now, yesterday itself for this project we added the additional libraries, right? So that these packages can be identified. Here we are writing import packages, right? So these guys can be identified. Why? Because yesterday itself we have added, for the project level we added. So no need to do any other changes. So you're not getting any cross marks here, right? That's fine. Now what we can do, just we have to create a jar file here. So this is our class, and by using this, we'll be creating a class file. So just say export, and after that select this jar file and say next. Select your project if and all unchecked, and go to browse, and on desktop, and you give any name. Suppose I want to give Naresh path here, or party, what can be partition to indicate, and please don't give any extension. That's it. And after that, let's say next, and please don't forget to mention your main class, because in a given project you will be having a lot of main methods here. So select appropriate one like this and say okay. So don't worry about the warnings and all, if and all they appear. That's it. Right, great. Now what we be observe here, so let us look into this. Okay, so a jar is created here, there is no problem with that. Now we'll run this jar on the given data set. So just we verify any data is there here, any word count data. Run our jar. Yesterday we ran on, right, no problem. We'll take one more new data set here, so that because hive and data are our partition keys, right? So we'll ingest similar kind of data here. Just a moment. Yeah, I'm having some data set here. So yes, this is a better data that I can see. So what I will do here, I'll just take this data to HDFS. So how to do that? So go to this, CD AMR and combiner and the partitioner. Here we are having the data. Just say HDFS and minus put path to HDFS. That's it. So now our data is available on the HDFS. That's great, really. Right. Now what I had to do, we had to run our job. Nothing but we had to run our jar file. So how to run that? So I'm opening one more terminal. Right, from here I'll show you. So CD desktop, and you can run as Hadoop jar and manage part1.jar, and the input data name is part, which is available on the HDFS, and you can say output name is part op. Anything you can give. So this is my jar name, and this is the input data set, and this is the expected. By this name, output data will be created. That's it. So it takes some time to run that. Right, it's taking some time. So right, it's really very fine now. Just say refresh so that it can reflect on the file system. So this is the output, part op. Look at here, it's created three partitions, 0, 1 and 2. So in the first partition, it's giving the count for Hadoop. So this is our partition key. In a similar fashion, in the second partition, it's giving about a data. So it's appeared 9 times here. In a similar fashion, the rest, it's giving the rest of the words in the count in the third partition, right? So like this, you can implement your partitions and combiner concept. So these two are optional, right? Based on the use case, you can implement. There is no compulsory to go with the partitioner and combiner. Now, we'll understand one more scenario here. Distributed caching. So same thing, right? We just ran in high as a map side joins, and in peak replicated join. In a similar fashion, the same concept here also. What we call in the map registers pattern is a distributed cache. So what happens here also, we are having two tables, right? And when you're having a small table data and when you're having a very bigger data. So small table it's kind of a lookup table. So what you can do here, instead of doing a normal join. So normal join means initially you're running the mapper process, then shuffling and sorting, nothing but the merging what we call. And then of course if and finally it stage into the reducer. So this is really expensive phase because although your data is going with multiple steps. So instead of that, if and all you're having a small table data and the bigger table data, so what we can do, we can keep the small table data in the main memory, right? We can push our small table data to main memory, and we're just creating a hash file, and we are trying to, join this hash file with our bigger table data. So by which we are eliminating or removing the additional process. We are not at all doing any shuffling and sorting. We are not at all doing any reducer. So everything is happening in the mapper side, right? So you're getting a good optimization level here. So how to improvise this? Look at this. I'm just having, you know, so the concept of distributed cache to which all trackers have to access to nothing but our small table data into which we are making a hash file. Now the hash file will be distributed to all the task trackers. Suppose your data is spread into multiple, are distributed to multiple nodes. Now all these task trackers will have the small table data, right? So the the data what you want to keep in, like the small table data that you're preparing as a distributed cache, or instead of that we can say we are creating a hash file and we are keeping it that into the distributed cache. It's all available to all the task takers, right? Then what happens? For example, this is a simple data set I would like to show you. I'm having a state.date where I'm having some, explanation for this TS, AP, and all the way. TS stands for Telangana, AP, Andhra, like the way just I'm having some states and the description, right? At the same time, I'm having some input file data. So these two are actually two data sets only. Normal join operation means how are you going to join? So based on this, you're going to join and you're trying to get the abbreviations for that, isn't it? But here we are implementing a distributed cache mechanism. So this is the small table data. So the abbreviations what you're having in a data set, we be considering this as a cache file, or as what you can say distributed cache, or simply a hash file. You can consider this. In the other way, you're having a very bigger data. So to join to these two tables, right? When straight away we are not performing any join. Instead of that, we are preparing this as a hash file and pushing into the cache, distributed cache, and we make sure that this is available to all the task trackers, by which we can perform the mapper task, local map task only. So we are not at all doing any shuffling and sorting. We are not at all doing any reducer job. Everything will be happening in the mapper side itself. So to improvise this, we need to have certain methods, right? And even some objects also. And what are the the methods and all? So first of all, we need to use this distributed cache dot add cache file method. So whenever you want to add, like in our scenario, you want to add this, right? This is the file what you want to distribute really, the small files. So this will be distributed via this particular method. Now this will be sent to all the nodes. Suppose your data is spread into 10 nodes. So 10 nodes, this particular file will be distributed via this particular method. At the same time, the file names here, just you get, for example, state.dat. Like I am keeping abc.dat, whatever it may be, the file that will be specified via this particular uni resource identifiers, what we call URI objects. So whenever you want to send, that will be sent via URI objects, file names. Okay, right? So your objects with our URI specification objects that we are sending that. At the same time, if you are not giving like this, then what happens? We assume that the file is present on the HDFS in the path indicated. So just now you have seen whenever I am running a MapReduce job, right? How I'm running, I'm keeping the file in the HDFS, and I'm starting running that, right? So here we are giving, while running the application, just we are giving the main file, I mean say main data set address only. We are not giving this small table data set because already we are dumping that into HDFS, but we are not mentioning in the command line. We are passing that via this URI objects. That you need to understand. Here I'm working on with the two data sets, right? One is an input data file and one is a cache data, for example. So while performing this map set join as the distributed cache, right? Anyway, these two data sets will be present in the HDFS only. But how I have run here, look at here, once again. So here while running, not here, here, right? So here I'm saying this is the jar file and this is the input data set and this is my expected output here, the folder, what I have provided. But the other one, we are sending two table data sets right now. So we are keeping two data sets in the HDFS, but we are saying, or we are mentioning only the bigger data set here in the command prompt. The small data set will be sent via the distributed cache, nothing but as a URI objects. So in the business logic itself, we'll be writing the path. I'll show you that. I'll show you that in the business logic. So no need to specify this additionally. Okay, I'll explain in the business logic, then you'll get that. At the same time, when you want to retrieve the files and all, you have to go with certain methods and all, like a distributed cache, get local, cache files and all, to retrieve the path where you kept this particular files and all. At the same time, right? How are you going to pass this information to all your local files and all? Nothing but your task trackers with the help of this map system directory, right? So this is here you can see I'm writing in my driver class try method, try cache method I'm implementing here. So try distributed cache, add cache file. So here I'm sending my, for example, my small table data as a URI object. Okay, this is already, if I'm saying slash, this is already available in the HDFS. So I'm not giving this path in my command line. I'm passing that via my URI. Got it? Because you're having a bigger table data and the small table data. Small table data, you have to pass via URI objects so that it will be distributed to all the nodes with the help of the main memory, isn't it? So that's the reason the bigger table data we are specifying in the command line and the small table data we are giving reference in the business logic itself by specifying that as a URI object. That's it, right? Then of course, this is how you can write your mapper reducer. That's fine. Of course, sorry, we don't have any reducer. Just we'll be having the driver in the mapper class here, right? So this is how you can implement. So in the driver class, we are just implementing the exception handling mechanism by using the try catch methods and all. So there we are saying, boss, I already kept the data in this location. Just find out this and send via as a URI object. That's it, right? So that's how you are sending that. So this is the normal join, right? You're having a table X and table Y. So mappers will be working and intermediate result will be generated. Then you'll be working on the shuffling and sorting phase. So then finally it's reaching to the reducer level and finally you're going to get the output. This is how exactly you're doing that normal thing. But if you're doing with the help of these map side joins on the distributed cache, then what happens? We don't have any other stuff here. We don't have the shuffling, set sorting. We don't have the reducer and all. Everything will be performed locally here, right? We are performing a map reduce local task and looking into small table data. We are creating a hash table file. We are sending this via URI objects, right? And here on the other end, you're having the bigger table data. Now this map is all doing the local map reduce job. So joining will be performed here itself. We are no way concerned about the reducers and all. Right. Now the same thing just will understand with a simple example here. Right. So here in the distributed cache I'm having abc.dat. So this is a small table data. Right. Just I'm having some abbreviations for this. UP stands Uttar Pradesh, MA Maharashtra, like the way. And of course this is my input. Don't worry about the data. Sometime Unix timestamp you're having, or the some population you can count, some population. So UP and this is the population, MA and this is the population. So just we want to combine these two data sets and we want to get the abbreviation for each name here. UP means Uttar Pradesh, like the way. That is our business logic, or you can say for the particular problem statement we improvise that. So just try to understand the business logic in this particular Java. So as usual, just start with the driver class where we are having the main method. Look at this. So just we are configuring the job and you're giving all the way, right? Look at this. We just provide the name to that and look at here. Set number of register tasks is equal to 0, right? We made that here itself. So earlier for the program we are running 3 registers. Set number of register tasks is equal to 3. Now here everything will be running on top of mapper. Nothing is required really with reducer. So that's the reason we made this as 0 here, first point. And in the exception handling mechanism, nothing but in the try catch mechanism, we are giving the address of this ABC. So we are passing this abc.dat via the URI objects. So this guy is finding whether it's available or not. If it's there, then it will run the other business logic. If not, it will throw an error. That's it. And after that, we just specified our mapper class name, output key class, value class, and everything, and command line arguments 0 and 1. This is for input and this is for output. Finally, job dot wait for completion true. So by looking at this, you have to say we are going to implement this with the help of the new API, isn't it? The way you are declaring, because we are not using anything. Earlier, the definition is different, and here the way you are implementing, nothing but you're triggering your job is different here. So we are saying job dot wait completion for is true. So all the way you're going with a new API. Even here you can find out the difference. In the old API, we are just writing map, right? But here we are writing the complete thing here. Hadoop map reduce. Now look at here. Sorry, what happened? Right. So if you look at here, so our mapper is extending the mapper class with these generics and all, that's fine. And after that, we are writing like, we're just verifying, we're passing that abc.dat. Nothing but we already mentioned, right? So how to read the data and how you are passing the information. So already we mentioned like, we are passing via that, you know, hard coding we're doing. The data name here you have to specify in the business logic itself. Suppose you're having employee.dat. Here you have to say employee.emp.dat as it is. So some kind of hard coding that we are doing here. And we are using these methods also. Distributed cache.get local cache files and all. So now what happens, this will be fetched, right? In the driver class, what you're trying to say here, you're passing the information via URI object. Now this class will take the responsibility, okay, what you specified in your mapper class. So this will take the responsibility. So we're setting a mapper here, right, inside the mapper once again. So inside the method we are specifying here, so AB map. So we are creating the hash map based on this given data, and this now will be distributed via this distributed cache dot get local cache files. Okay, we are having a data file initially, and with the help of that we're just creating the hash map and we are distributing via this, okay, distributed cache dot get local cache and this particular cache files method and all. So what we are doing here, we're just like, line dot split. Based on that we are just comparing whether we are having any data or not. We are initializing to token 0, then we are verifying the states whether the data is available or not. Then finally ab.state, nothing but the abbreviation and the state followed by something like, TS Telangana, AP Andhra Pradesh, like the way. So these are the values that we want to pass, because we want to find out the abbreviation for that, right? So we are giving the same information here. So in the output the same thing will be specified. That's it. So this is what exactly we specified in our mapper class. So whenever it's having any issue, this will be displayed, unable to load the abbreviation data. That's it. And this is about our mapper functionality here. Okay. So initially just we are comparing that is the, tokens. I mean to say whether here you're having any data or not at present. Okay. So it will be confirmed whether the data is there, then only you're going to get that. Okay, so actual data you have to read, right? So how it going to read the data? With the help of this inab and all, right? So string inab, just to define this relation or a variable, we can say tokens is equal to 0. So then after that, the data what you are giving here, nothing but the abbreviation data. UP means Uttar Pradesh, MA means Maharashtra, that will be fetched via this particular thing. Then finally, what is your key and what is your value? Output key will be your state and output value will be your row. So key will be state here, Uttar Pradesh, and the complete row will be displayed along with that. That's it, right? Anyway, already we have seen what we specified in our driver class. So here intentionally we made number of reducer task is equal to 0. So no need to worry about the reducer class and the other stuff. So what we'll do is initially just we'll keep these two data sets in the HDFS. Okay, right. Let us do that by saying cd distributed cache and HDFS DFS minus put abc dot, and the other data set name is DC input, right, to HDFS. So both we kept in the HDFS. That's fine. Now what are you going to do? We just will create a jar file with the help of this particular business logic or the program. So let us do that. I'm creating a one more class for this. Okay. Right. See, in modern way, this is deprecated. Some methods what you're using here you're getting. We are not sending like this the URI objects. The mechanism is modified, but I don't want to confuse you now. Okay, at this moment. Here, the context message, how you specified. It's everything it got changed actually. Some deprecation. But don't worry, it will run. Right. So let us create a jar file by saying export. So I'm saying Naresh DC. Please remove the extensions. Okay, this is the jar file. And next, select your main class. This is the one. And say finish. That's it. Now a jar is created. Right. Now we'll run. How to run? So Hadoop jar, and the jar file name is dash dc.jar and provide the input. So dc input. No need to specify this abc.dat because we have sent all the way as a URI objects and dc op. That's it. It will take some time to run anyway. Right. Look at here, it's completed very fastly here because it's not having any reducers. Here I can see map 0 reduces 0, map 100% reduces 0. That is the application, right? So generally what happens, reducer will also reach to the 100%, then you're going to get the result. So now everything happened on top of the mapper, and intentionally we just did everything on top of the mapper here. That's fine. So we don't have any reducers here. Now you got the output here. So here you can see very clearly it happened with the help of mapper. Generally we are getting as a OR here. So now it abbreviated. Okay. So this is your key and this is the value it's giving. Uttar Pradesh, UP, Maharashtra, MA. It's comparing and it's providing the values like this. This is how you can do the distributed caching mechanism. And now, right, it's why it's showing poor network. One second.
This conference will now be recorded.
Fine. Now coming to the counters. So before talking about this counter, just we recap what we to this particular terminal. So just now we ran a MR job, right? Map reduce job for a particular problem statement. Like we want to join two data sets using the distributed cache mechanism. So if you look at here, it's giving some information, right? Suppose it started and ended and this is a job ID. And apart from that, if you observe, it's giving some counters, file system counters and job counters, map and some other file input format counters, file output format counters. So like the way you're just getting some counters, right? So these will be known in, sorry, this will be known as some built-in counters. Apart from that, what you can do, even we can also give our own counters. Like you just are having some point of sale data, and you want to know how many records processed for every month, how many processed, whether a records processed in a particular given month or not, how many processed in December, January, February, like the way, right? So what we can do, we can provide our own counters also. Like otherwise, you just see how you have processed some data. Maybe how many good records you processed in a given time and how many bad records do you have processed. So like the way, whenever you want to go with your own counter. So apart from this, right? Apart from this built-in counters, if you want to, right? If you want to go with your own stuff, you can go with that, right? So fine. So how to define our own counters? We'll understand that now. And for example, yes, let me show the data set initially with the counters. I'll close this. Yes, this is the data. So this is the data, and just of course it's in the Unix tabs. So it's saying one record processed in this particular given month and two records processed in this given and then 3 and 4 like this. Some sample data, some POS data. So don't worry about the data here. Well, the only thing is, first of all, we need to convert this into normal thing, like in the month fashion, like Jan, Feb, March, like the way, and we want to get the count. How many records processed in a particular given month? That is our main intention here. So how to implement our own counters? So what is the way here? So counters, these counters are nothing but the lightweight objects, what you can call in Hadoop, right? Which allows us to keep the track of the system progress in terms of the mapper and reducer. That's fine. So this just now we observed in the MR dump, like I have shown you in the console, right? So that is known as technically as MR dump. So it's giving a lot of information, lot of information, like like how many input records it processed and output records processed, like the way. So this is what we observed just now. And here, same information can be get if you open your browser and if you say localhost 5030 and jobtracker.jsp, then what happens? It's giving all the information. The same thing, same information what you're getting on the console will be displayed like this. How many jobs, how many completed jobs, and what are how many job counters, file system counters, and the map reduce counters. So based on this job ID, okay, a job ID also will be created, right, whenever you're running. So with the help of the particular job ID, if you click there, then you'll be getting complete information, right? So if and all it's only the mapper process or reducer, so how many reducers it's taken really, so complete information. The only thing you need to give is localhost 5030 and jobtracker.jsp. That's it. That's fine. But if and all, if you want to go with our own thing, okay, how we can go with that? The simple thing here is, yeah, of course, already we discussed about these counters. I'm not going much with this, like input records and output records and all these guys. So just straight away come to the point. There is something like custom Java counters. So nothing but we can just go with our own thing instead of going with the regular. So how to define here? So for that we'll be taking the keyword called enum. Nothing but just we are grouping. We are grouping the related information. For example, month-wise you want to get the count for a given data set, for a particular point of sale data. So just create your own group or with your own counters group with a word called enum here. So here I said simply I'm having some records processed and out of which I just want to find out the good records and the bad records. So for that, what I had to say enum, my counter and good and bad. That's it. You know what happens? So based on the records processed, I will be getting the count for the good and I'll be getting the count for my bad records also. Right. So how I can achieve this? So just I have to say public enum and your counter name and you specify the counters. So this is the group actually. My counters is a group you're defining with the help of a keyword called enum, and these two are the counters here, good and bad here. So based on that, you're writing some you are incrementing here. Okay, it's not intimate, it's a spell error here. So here it's a increment. Okay, increment one here. Let me correct here as well. Type error, right? So just you have to give the you have to use this with the help of the context, right? Context method, and just you have to specify how many records that really you processed a good records and the bad records on the given data. For example, just now we have seen some sample data we are having with a Unix timestamp, and we need to find out how many records processed in the month of March, May, June, whatever it may be. So the data actually available in, right? The data is actually available in the Unix timestamp. So initially what we'll do, we use the available Java functionality to like date time. We are having a date and all. So we are converting the Unix timestamp to the regular date format and we are getting the count. So how to do that? So we'll just understand with a simple thing here. So let me open the business logic, right? So this is the data. Already I think I have opened the data. So coming to this. So here what I said, I just said class my counter. That's it. After that I said month, enum month. So enum is a keyword to represent a group of counters. December, Jan, and February. These are the counters, and this is my counters name here. That's it. So this is the data what you're having, but this is completely in the Unix timestamp. So here I'm writing a date functionality by which I'm converting the things to regular date format. Okay, so this is the simple business logic what I'm implementing here. And I'm writing the other thing also. If and all this equals to 11, so the December month should be increased. And if and all you found some records with related to 0, then that Jan has to be increased. Similarly, if you got 1 after conversion of the Unix timestamp, the February month records has to be incremented. So finally, it has to write output. So of course, if you verify in the HDFS output, you'll be getting out and out. That's fine. We are not looking with this success and success. So this success only written 2 times here. Our intention is we have to get the counters, right, in the MR dump. That is our intention. So how to achieve that? So in the main method, we are writing the business logic for that, right? So we assign the name for our job and nothing to do with the reducer. So we made this as a 0. And what is your mapper class and what is your output key class and output value class and command line arguments, input and output path. We just specified. And finally, we are saying job dot wait for completion is equal to true. And this will be displaying the counters on our, MR dump. And this is actually not required. You can omit this particular business logic also. Okay, this is fairly not required. It just display okay, in February we just processed these many records, in March we have processed these many records like this. So this is not required. Actually, you can stop your business logic here itself, right? Anyway, the counters will be displayed, not a problem. So what we'll do, we just run this job and verify the output. It's very simple, right? Reducer is nothing required really here. So initially we are taking the data and we're converting into a string by saying value to string, and after that we're taking a existing default functionality called date, and after that we're converting the things to regular date format, like you're just giving some if it matches with 11, so December related records has to be incremented. That's it. So let me take this data set and copy to the HDFS. Yes, sorry, not HDFS, to my Eclipse. I'll create here, take this and say class, give anything, not a problem. We'll change that later. Right, that's fine. Right, that's great really here. Now that's fine. So I will change this business code into compilation unit to counter. That's fine. And I'll be creating, yes, I'll be creating a chart file now by saying export and just give a name for this, Naresh counters. That's it. Next, select the main one, finish. Right. So what we'll do, we'll take this data to HDFS. So the data name is, sorry, counters underscore data. So right, the data is available in the HDFS. So now we'll open one more terminal, and from here we'll be running that. So now you're getting additional counter information. So these are the built-in counters. So apart from that, we'll be getting our own counters also. So how to do that? Right, just run this DFS, sorry, already we copied, so we'll run the jar file. So Hadoop jar, and the jar file name is Naresh counters. Why it's not taking? I think we have given some other different name. Just a moment. Okay, I missed the H here. Right? And what is the input? This is the input, right? Counters underscore data. I'll be giving the same thing. And counter out. Actually, in the output folder, nothing you're going to get. Just you're getting the information on the console only. AMR tab. Only you'll be getting the success message. That's it. Right? So here you can see very clearly. So this is the additional information. It's not required, but look at this. Our counter is like Naresh my counter, the month counter what you define. So it's giving. In the month December, it's processed one record. In the month of January, it processed some 6 records. So like the way, apart from the built-in counters, you can go with your custom counters also, right? And if you verify the output here, absolutely you'll be getting nothing. If you say browse the file system, right? So where is that counters output? Just refresh. Here only you're getting the success message because that will be displayed on the console only. That's fine. So like this, based on your problem statement, you can run n number of MapReduce programs. Procedure remains same, just you have to go with the template and define your business logic, create a jar file, run on your data set. And this is really useful when you're doing any good batch data processing. Like, you're having some terabytes of data and you want to do any analysis on the data. Like, maximum and minimum temperature you want to find out, or based on the POS, point of sale data you want to work on a particular certain requirement. All these things, you can work on fairly. But it really missed out the real-time behavior. Whenever you're talking about the real-time processing and all, this MapReduce is not a good choice. This is only suitable whenever you're having the batch data. Of course, I'll tell you, later how we're going to implement the same thing in the real time. So anyway, you're having the Spark and Scala session, right? That time I'll tell you what is the real time really, and what is the architecture. Simple architecture we'll understand in that time. So batch data is fine, of course, but in real time, you want to process any real time data and all how it's going to be processed. That's mainly important thing. So Spark is having more advantage there only. Okay. So if and all you want to go with a batch data processing and all, Hadoop is the best choice. But if you are looking for any real-time processing and all, Spark is the ultimate choice for you. Okay. But anyway, we'll discuss those things in our Spark and Scala session. That's fine. Now, what I will do is today just I will share some document to you, Naresh. Please go through that. Let's share. Where is that? Yes. So here in this document, I just specified what are the packages we need to go with and what are the classes and methods and what is the purpose. So this like is pretty much required whenever you're working with a Java APIs and all. So HBase we have seen we are using put whenever you want to insert some data just or creating how to create the table date and how to insert some records, put, scan, all these methods we have seen, right?
Yes,
Now if
yes,
you
sir.
want to use as a Java API, yes. So remotely you want to access. Just imagine or consider like your enterprise may be working with a just they enable some thrift services or any RESTful web services they enabled. So your server is working all the all the way outside of your location. Nothing but it's working as a remotely. Then what happens? You are not be able to access any shell. You can't access any HBase shell and all. So that time what I had to do, ultimately you have to go with this HBase Java APIs only. So here you need to write the business logic for creating a table, for inserting some records, for for deleting, adding, and what it may be, updating. So everything has to be specified in your Java API only. So for that, some classes and related the packages are really helping us. So here in this particular document, I given the list, complete list I mentioned. So what are the tables and methods will be really helping us for creating a tables and for adding the data, because here we are doing in all the way separately. Here we are having a column families, column qualifiers, right? And date will be inserted for all the records, even though we are not giving that. So here everything we are not even having the data types also. Everything in the byte array format only, right? We are not having any integer character data like the way. So everything will be in the byte arrays format only. So that's the reason how to specify that which format is really supported that, and how to start and how to close finally, and how to insert some values to that. So how to read the data here. So what are the methods and classes and respective packages are really supporting that, and what are the steps it will follow. Similarly, what about this one, deleting the data? How are you going to do? And how to scan? Scan means complete records will be displayed. Get means only a particular record will be nothing but particular. Maybe you are accessing only based on the row key ID and all, right? That time we can go with the get. Alternatively, scan will fetch all the records. So just I have given the complete information, the classes and the constructors and everything here. Yesterday really I forget to share this document, but anyway, today I will share with you. Please go through this table, and it will be very useful because in tomorrow session we'll be working on this Java APIs. I'll be showing two examples. So that time this knowledge is pretty much required. I'll be sharing this. Please go through that for tomorrow's session. That's fine.
Okay.
And meanwhile, we'll take just 5 minutes break, and after that, I'll show you, a data use how you can do the bulk data using Pig and MapReduce. Okay,
Sure,
just
sir.
will take 5 minutes break, and I'll show you two examples, and I'll share this also later. Yeah, just for 5 minutes.